Hi everyone, welcome to Go Classes. In this lecture we will study recurrence relations. Okay, recurrence relations for sequences. So before we start recurrence relation, let's study what is a sequence. Sequence is basically ordered list of elements. So what it means? It means this is a list of elements in which order matters. Okay, so for example 1 2 3 5 8, this is a sequence. Okay, this is another sequence. Now you can notice that sequence is ordered. First of all, these are the properties of sequence. So first of all, sequence is ordered. Okay, ordered means order matters. It means this sequence, you can notice this sequence, this is not same as this sequence. Both are different. Okay, so this is the definition of sequence. Sequences are ordered list of elements. So sequences are like this. Okay, so in sequences we have A0 element, we have A1 element, we have A2 element, we have A3 element, and so on. Okay, so like this we have our indexing. We will start with 0. Okay, when we discuss sequences, then most of the time in general, basically the index, the counting, we start from 0. So this is our 0th element, this is first element, this is second element, this is third element. Okay, so this is our 0th element. Okay, so 0th element. So normally in general, this is a convention that our in a sequence the counting we start from 0. So this is A0, A1, A2, and so on. Okay, now you can notice this sequence. Okay, so this sequence, this is different from this. Both these sequences are different. Now why they are different? Because you can notice that in this sequence you can notice that the 0th element is 0. Okay, and the first element is 0. But here 0th element is 0 and the first element is 1. So they are different sequences. Remember, they are different sequences. Okay, so this is the definition of sequence. Sequence is basically ordered list of elements. Okay, now once we have seen what is a sequence, now we can see what is a recurrence relation. So what is a recurrence relation? Recurrence relations basically occur, okay, most of the time recurrence relations occur when some term in the sequence that depends on the previous term of the sequence. Okay, so with example this will be clear. Basically we want to say that in the sequence some term, okay, if you have some term an, okay, so that depends on some of the previous terms. Okay, so you have a sequence, A0, A1, and so on, you have sequence. So recurrence relations occur when some this term an, okay, it depends on some of the previous terms. Okay, so in this situation recurrence relations occur. For example, let's take for example arithmetic sequence. Now this is a very simple sequence: 3, 8, 13, 18, 23, 28. So this is arithmetic sequence. In this sequence you can notice this is our A0, this is our A1, this is our A2, and this is our A3, and so on. Okay, now in this sequence you can notice that any term, whatever term you take, for example if you take this term, okay, this is your A4. So if you take A4, then we can notice that A4 depends on A3. Okay, so you can notice that A4 depends on A3. As I told you in the recurrence relations, okay, in the recurrence relations, if we have a term an, so okay, so any term will depend on some of the previous terms. Now here you can notice the any term, whatever term you take, so that depends on the previous term. A4 depends on A3, so I can say that A4 is equal to A3 plus 5. Okay, similarly A3 depends on A2, so I can say A3 is equal to A2 plus 5. And similarly A2 depends on A1, I can say A2 is equal to A1 plus 5. Okay, now similarly this A1 depends on A0, so I can say A1 is A0 plus 5. And A0 is basically the starting point. Okay, so this A0, this is the initial point, so this is fixed. The initial point is 3. Okay, so this is just an initial point. Okay, now this is initial point, and after this every term, whether that is A1, A2, A3, an, every term depends on the previous term. Okay, so this is your arithmetic sequence. So you can see this is a recursion. This is a recursion. What I mean that if you have any term an, if we take, so that depends on the previous term plus 5. Okay, so this is the recursion here. Any term, whatever term you take an, so that depends on an minus 1. And okay, so you can notice Now let's see another very popular sequence, that is Fibonacci sequence. This is also very popular. Okay, what is Fibonacci sequence? So Fibonacci sequence is basically like this. You can notice here, okay, 0 1. Now you can notice, okay, so these are the initial points, these are the initial conditions, these are known as initial conditions. Okay, so these are initial conditions. Now you can notice that any term, whatever term I write, that depends on the previous two terms. For example, this is A0, you can notice this is A0 and this is A1, and now A2 is basically summation of A0 and A1. Okay, so A2 is basically 0 plus 1, and now A3 is basically summation of A2 plus A1, so that is 2. Now A4 is summation of previous two terms, so that is 3. Now the next term is summation of previous two terms, that is 5. The next term is summation of previous two terms, that is 8. The next term is summation of previous two terms, that is 13, and so on. So this sequence, this is a very popular sequence, that is Fibonacci sequence. Okay, very popular, very standard. So you can notice that in this Fibonacci sequence, what I can notice, that in this Fibonacci sequence, okay, in Fibonacci sequence we can notice that any term an, that is basically summation of an minus 1 plus an minus 2. Okay, so any term is summation of previous two terms. Okay, and we have initial conditions also. So what are the initial conditions? So initial conditions we have that A0 is 0 and A1 is 1. Okay, so you can notice that these are the initial conditions. Okay, so we have A0, that is 0, and A1, that is 1. This is your A0, this is A1, and now this recursion, okay, this starts from a greater than n greater than equal to 2. So you can notice that A2, okay, what will be A2? A2 will be A2 minus 1, that is your A1, plus A2 minus 2, that is your A0. So A2 is basically A1 plus A0. You can notice A2 is basically the summation of previous two terms, and A3 is summation of previous two terms. Okay, and A4 is summation of previous two terms, and so on. So every term, you can notice every term that depends on the previous two terms. Okay, so this is called recursion. Okay, so this is one more example of recursion. As I told you, the recurrence relation, okay, recurrence relation that occurs when some term depends on the previous terms. Okay, you can notice in this sequence, every term depends on only the previous term. A4 depends only on A3, but in this sequence you can notice that every term depends on previous two terms. A4 depends on A3, A2. Okay, so that is the reason I told you that in recursion, or you can, okay, in recursion, or you can say in recurrence relation, I can say that any term that depends on some of the previous terms. Okay, some of the previous terms. So this may depend on one term or two term or three term, and so on. Okay, so as we have seen two examples, in one example this is dependent only on the previous term, in one example this is dependent on previous two terms. Okay, let's see one more example. You can notice that recurrence relation, that is everywhere. Okay, for example, this is your set of natural numbers. We know this is a sequence of natural numbers. Now here we can notice that here also there is a recursion. Here also I can say that every term an, that is basically the previous term plus 1. Okay, so here, and what is the initial condition? The initial condition is A0 equal to 1. So this A0, this is 1, this is initial condition, this is known as initial condition. So initial condition is this, and after that you can notice that n greater than or equal to 1. Okay, so this is initial condition. After that, every term depends on the previous term. So for example, you can say that A5, that is basically equal to A4 plus 1. Okay, like this. So this is another example of recurrence relation. Now, so let's see the definition of recurrence relation. So recurrence relation for a sequence is an equation. Okay, that equation expresses an in terms of one or more of the previous terms of the sequence. Okay, so as I told you, recurrence relation for any sequence, if you have a sequence, this is your sequence, okay, so for this sequence, recurrence relation is just another way. This recurrence relation, this is just another way of representing this an in terms of some of the previous terms. This an will be represented, okay, in terms of one or more of the previous terms, okay. So that is called recurrence relation. So this is just a way of representing, remember, recurrence relation, this is just a way of representing an as a you can say in terms of few of the previous terms, okay. Now let's see example. So consider this example. Consider the recurrence relation. A recurrence relation is given to us. So this is your equation. This is just an equation. But remember, we also need initial condition from where to start. Okay. So that also we need from where to start. So you can notice that what sequence do we get if the initial conditions are a0 equal to 1, a1 equal to 2. Okay. So the first question is, the initial conditions are given and the initial conditions are a0 equal to 1 and a1 equal to 2. These are the initial conditions. They are given to us. And now the question saying that this equation is also given. So this is equation and these are initial conditions. Okay, two things we need. So we need the initial point from where to start, and now we can create any, okay, and also we need the equation, and the equation is an. This is the equation. You can notice an is equal to 5 of an minus 1 minus 6 of an minus 2. So 5 of an minus 1 minus 6 of an minus 2. So from here you can notice that I can calculate a2. What will be a2? The initial condition are given and the equation is given. So a2 means 5 of a2. So n equal to 2. Now you can notice n equal to 2. So 5 a1 minus 6 n equal to 2. So that will be 6 a0. Okay. So what it gives? It gives 5. A1 is already given. The initial condition that is already given. Okay. Minus 6 of a0. So what is that? That is 4. So we got a2 equal to 4. Now we can calculate a3 also. What is a3? From this equation we can get a3. We can notice that a3 is basically 5 of the previous term, 5 of the a2 minus 6 of the a1, okay. So you can notice this value, what this value will become? This value will become, okay, 12. Sorry, this value will become 8, okay. So this a3, this will become 8. Now we can calculate a4 also. What is a4? This equation, remember this equation, what this equation is telling? This equation is saying that an, okay, any term that is basically 5 multiplied by previous term minus 6 multiplied by an minus 2. So what is a4? That is 5 multiplied by previous term, okay, minus 6 multiplied by a2. So that is 4, okay. So here you can notice that is, okay, so this value we got 16. Yes. So finally what sequence we are getting? So sequence is this this is your sequence a0, a1, a2, a3 and so on. This is your sequence. A0 is already given to us, that is 1. A1 is already given to us. These are initial conditions. They are given to us, and now we can create a2, and a2 we have found. A2 is 4 and a3 is 8 and a4, what is that? That is a4. So a4 we have counted, that is 16, okay. Now we can similarly count a5. What is that? A5 is basically, okay, what is a5? That is 5 times 16 minus 6 times 8, okay. So that will be your a5. Like this we can count a6 and so on, okay. So very simple. This is how. So you can notice in this recurrence relation is given to you, equation is given to you, initial condition is given to you, so you can find the sequence. So this is the sequence that we will get. So finally this is the answer. This sequence we will get 1, 2, 4, 8, 16 and so on, okay. You can notice this is a power of 2. So the next term, I think that will be, okay, so that will be 4, okay. So the next term you can see, okay. So yeah, okay, so that is 80 minus 48, okay. So finally what you got, and so you got 32. Okay, so now you can notice that the next term is 32. So I can say this is the sequence we got. Okay, 32, and the next will be 64, and so on. So this is the sequence we got. Okay, now let's see the second question. And the second question is, the initial condition are changed. Remember, the equation is same. The equation is same, 5 times an minus 1 minus 6 times an minus 2. So this equation is same, but the initial conditions have changed. Okay, so now because initial conditions have changed, so our sequence will change, because now initial condition is a0 is 1 and a1 is 3. These are the initial condition. So we have sequenced this. Okay, 1 3, and what will be a2? A2 will be 5 times a1 minus 6 times a0. Okay, so that will give us 9. Now next you can notice a3. What is that? A3 is 5 times, okay, the previous term minus 6 times, okay, so this, so that, okay, that will give me, so what value we got? So here we got, okay, so here we got 27. Okay, now you can notice, so this is the point. And similarly you can find a4 also. A4 means 5 times the previous term minus 6 times the term previous. Okay, like this. So what sequence we got? We got, these are the initial conditions, they are given to us, and after that a2 is 9, and then a3 is 27, and then you can notice basically we are multiplying with 3. So I think the next term will be 27 multiplied by 3, and so on. Okay, so this is the sequence we got. Now you can notice, one thing you can clearly notice is that when we change initial conditions, then the sequence is changing. You can notice the equation is same, the recurrence relation, the equation is same, but the sequence will change. Here the initial conditions are different, here initial conditions are different. So sequence that we get from for the second question and for the first question, the sequences are different. Okay, so finally the final conclusion, what is that? The final conclusion is this: recurrence relation. Recurrence relation is basically for any sequence. If you have any sequence, okay, whatever sequence you have, now for this sequence, recurrence relation is just a way of representing term an. Okay, this is just a way of representing an in terms of previous terms. Okay, so we have an equation. Okay, in this recurrence relation we have equation that expresses an in terms of one or more of the previous terms. Okay, and also we have initial condition. So these two things we need equation, and we also need initial conditions, because I told you if initial conditions change, then sequence will change. Okay, so equation with initial condition, they will give me unique recurrence relation. Okay, so now you can notice, let's take this example. So for example, here the equation is this is the equation. Okay, so this is the equation for n greater than equal to 2. See, okay, here actually what this means, n greater than equal to 2, what it means? It means our recursion is starting from a2 onwards. So this means our recursion, remember, our recursion starts from a2 onwards. Okay, you can notice our recursion start a2 onwards. Now, so this is the point. And what happens with a0 and a1? What will happen with a0 and a1? What will be a0? What will be a1? These are initial conditions. So they are given to you. Initial conditions are given to you. So remember, these are initial conditions. They are known as initial conditions. And our equation, this equation is telling us that we can calculate any term an, okay, by the previous two terms. So any term an, that is an minus 1 plus 2 an minus 2 for n greater than equal to 2. N greater than equal to 2, it means our recursion starts from a2 onwards. Okay, and what about a0, a1? They are already given. These are initial conditions. So what is a2? What is a2? We can very easily find a2, that is previous term, okay, a1, that is basically, okay, previous term, I can say previous term a1 plus, okay, 2 of the okay, n minus 2. You can see n is 2, so it will be 0. So finally a2 is what? A2 is 5 plus 2 multiplied by 2, that is 5 plus 4, so that will be 9. This will be A2. Okay, so you can notice that our A0 is already given to us, that is 2. A1 is already given to us, that is 5. Now you can calculate A2, and that will be 5 plus twice of 2, that will be 9. Similarly, we can calculate A3 also. What will be A3? A3 will be A2 plus twice of A1. Okay, so it will be A2 plus twice of A1, that is 5. Okay, so it will be basically 19. So like this. Okay, so this is how we can create the sequence. So our sequence will be A0, A1, then A2, then A3, and so on. So this is how we will get our sequence. So this is the sequence we get. Okay, so like this. So very simple. Now remember, this is very important point, that the initial conditions are important. It means from where your recursion is starting. For example, consider this example. Okay, let's take an equal to an minus 1 plus an minus 2 plus twice of an minus 3. Okay, now you can notice that here in this equation, every term that is represented in terms of the previous 3 terms. Okay, so because every term is represented, this term an, that is represented in terms of previous 3 terms, so we need 3 initial conditions. Okay, so our recursion, this will start from n greater than equal to 3, and we need 3 initial conditions we need. Okay, so we need A0, we need A1, we need A2. Okay, so these 3 initial conditions we need. Once we have these 3 terms, okay, if you have A0, if you have A1, if you have A2, these initial conditions if you already have, then you can calculate A4. Now you can very easily calculate, you can calculate A3. Now very easily you can calculate A3. A3 will be A2 plus A1 plus twice of A0. This will be the A3. Okay, so you can, these are initial conditions, they must be known to you, because we need 3 initial conditions. Why? Because every term, this term an, this is represented in terms of previous 3 terms, so we need 3 previous. Okay, you can notice 3 initial conditions we need. Now you can calculate A3, now you can calculate A4, now you can calculate A5, and so on. Okay, because remember, if initial conditions are not given, then okay, then we can get many different sequences we can get. Okay, if only the sequence is given, okay, equation is given. Okay, so for example, only the equation is given to you, and that is your twice of an minus 1 minus an minus 2. Consider this equation. Okay, now if you consider this equation, then you can notice that this equation, this is satisfied by many different sequences. For example, this sequence also satisfies this equation. You can notice. Okay, this sequence, this also satisfies this this equation. Okay, so this sequence is also correct for this equation. You can give another sequence, you can give. Okay, so for example, what sequence you can give? You can give this sequence also, 0, 5. So what I can calculate? I can calculate, that is 10. Okay, and then I can calculate 20 minus 5, that is 15, like this. Okay, so this sequence will also, this sequence, okay, that will also satisfy this equation. You can notice that because we do not have initial condition, okay, if we have initial condition, then we will get unique sequence. So I can say that equation, okay, so I can say equation plus initial conditions. If I have initial conditions also, so equation plus initial conditions, they will give me unique sequence. Okay, they will give me unique sequence. Okay, so here you can notice that if we have initial condition, for example, let's assume these initial conditions we have A0 equal to 5, A1 equal to 5. If these initial conditions we have, then we will get only this sequence. Then we will not get this sequence. We will only get unique sequence we will get. But if we have these initial conditions, A0 equal to 0 and A1 equal to 5, if these initial conditions are given with this equation, then we will get this sequence. Then we will not get this sequence. Okay, so this is the point. Now, so let's see this example. find the recurrence relation for this sequence. For this sequence, we want to write recurrence relation. So this is simple arithmetic sequence. So you can notice that any term an, any term that is basically the previous term plus 4. Okay. So this is how I can write the recurrence relation. I also need the starting point, means initial condition. So what is the initial condition? The initial condition is a0 equal to 3. Now you can notice that every term I am representing in terms of the previous term. So an is basically an minus 1 plus 4. Okay, so every term is dependent on the previous term. Every term is dependent on the previous term. So you can notice this equation, this recurrence relation with initial conditions. Okay, these two will give me unique sequence. So these two together, recurrence relation and this initial condition, they will give me this sequence. Okay, let's see this example. Find the recurrence relation for this sequence 2, 6, 18, 54, 162 and so on. You can easily notice that every term is basically 3 multiplied by the previous term. So you can notice every term an. Okay, for example, here you can notice this is your a0. Here you can notice this is your a1. This is your a2. This is your a3. You can notice a3 is basically twice, okay, 3 multiplied by a2. You can notice a2 is basically 3 multiplied by a1. Okay, and you can notice a1 is 3 multiplied by a0. So we can notice that every term is basically 3 multiplied with the previous term. So this is the recurrence relation. This is the recurrence relation, and we also need initial condition from where to start. So a0, that is equal to 2. So this initial condition with this recurrence relation, they will give me unique, these two together, they will give me unique sequence. This sequence I will get. Okay. So this is very simple point. Now let's see, find recurrence relation of this sequence. So this sequence is given to us 2, 13, 27, 55, 111. Now a simple observation, if you do a simple observation, will tell you that every term is basically, what is that? Every term. For example, here you can notice a1. This is a1. This is basically, you can notice that this is a third. Okay, so you can notice here we need actually we also need, so this sequence, so let me write this sequence again. So in this sequence we have a mistake. So I think there is, here we have, so in this sequence there is some mistake. Actually this sequence it is starting with 6. So now we can notice that with small observation we can notice that a1, this a1, this is a1, this is basically twice the, okay, a0 plus 1. Similarly you can notice a2, this is a2, you can notice this is twice a1 plus 1. So I can say that every term, that is twice the previous term plus 1. Okay, so this is recurrence relation, and the initial condition we need, see here every term is represented in terms of previous term. So an is represented in terms of an minus 1. So we need one initial condition. What is that? a0 equal to 6. This initial condition with this recurrence relation will give us unique sequence. So this sequence we will get. Okay, so very simple example. Now, okay, so in the next lecture we will see what is recursive function. Okay, so in this lecture we have seen what is recurrence relation for sequence. The definition and some examples we have seen, but we will take a lot of examples, a lot of sequences we will take, and we will write recurrence relations for them. Okay, so far I have taken only easy examples to explain what is recurrence relation. Okay, so what is recurrence relation for a sequence, so this we have already seen. And in the next lecture I will tell you what is recursive function, and then we will see some examples. Okay, some tricky examples we will see on how to write a recurrence relation for a problem. If you have a problem, some real life problem we will take, and we will write a recurrence relation for those problem. Okay, so thank you everyone.